Hello everyone. In this video, we are going to see some of the basic concepts of exponent and power. This video is more helpful for all the grades above 6. So before proceeding with this, let us know what is an exponent. See, I may have 2. 2 is a number, so I want to multiply that nearly for 10 times. So how can I express that as an expression? 2 into 2 into 2, like till 10 times I have to express it. Instead of representing like a long expression, we are going to use an exponent form. It means if I'm repeatedly multiplying the same number for several number of times, we can represent that as the number to the power how many times I have to multiply. So it is so simple to mention. See, here I have given an example. 2 is multiplied for 5 times. So instead of writing like this, we are going to write in the form of exponent. See, 2 to the power 5. So it is a simpler way of representing a longer expression only when a same number is multiplied for several number of times. Now, what is the general form of this exponent? So now I'm going to say x is a number. It is repeated for n time. Then I can represent this as x to the power n. Then what is x and what is n? We need to know the names of those, right? So n is nothing but I can say it's a power or index of a number x. And what is x? It's a base. Which number is going to be repeated for the number of times? So this is what the very basic notation of the exponent form. And in exponent and power, we are going to follow certain rules. So let us see the first rule. See here, if the exponent having same base with the multiplication operation in between them, we can add the powers. So I can generally represent like this. A power x and a power y. See, both are having the base a, but the power is different, x and y. So we can add those powers with the same base. See, for example, I may have 2 to the power 3 into 2 to the power 2. This into multiplication is a very important thing because we can apply this rule only when there is a multiplication operation is exists between the two exponent. So that what I can do, the bases are same, so we can add the powers. So it's going to be 2 to the power 5. So this is how we will be proceeding. This is the first rule. Let us see the second rule. If the exponent having same base, but instead of multiplication, now we are going to have a division operation. Then what we are going to do? Subtract the powers. So let's see the general format. See here a power x, division is there, a power y. So we are just subtracting the powers. Same example only we will take 2 to the power 3 divided by 2 to the power 2. Then what shall I do? I can do here like this. I can subtract the powers so that it will become 2 power 1. Even the same thing I can represent in the another way also. Instead of using the rule, we can do one more way also. See here, 2 power 3 is upside in the numerator divided by what is the divisor? It is 2 power 2. So 2 power 3 can be written as 2 power 2 into 2 power 1 based on the first rule divided by 2 power 2. So I can cancel this 2 power 2, 2 power 2. So my answer is going to be 2 power 1. We can mostly we will be using like this when we are going for the higher grades. But as of now, as a rule, you need to know what is this. So if there is a division operation comes, we can subtract the powers. Now, what is the third rule? Yeah, this is again one more important rule. If one exponent is there, but it is having two powers, that means power to the power is there. It means like this. A power x also is there. And see, this whole exponent to the power y also is there. So basically what form it is? A number having two powers. So if any exponent having power to the power, then we will multiply the powers. So for an example, I can write like 2 to the power 3, the whole to the power 2. Then what I have to do? I have to multiply the powers. It is 3 into 2, so that my answer is 2 to the power 6. So these are the three rules of exponent. Still, the next rule. So if the exponent having different base with same power, till now we have seen same base different power. Na? So now we are going to see different base and same power. So you can combine the base and put as a same power. See, for example, I may have 2 to the power 3 and 5 to the power 3. So what shall I do? I can combine this 2 and 5 together and make a power single power as 3. So I can write it as 10 to the power 3. So this is what this rule says. And the next rule, same. Here it is multiplication operation in the fourth rule. Now I am going to have a division operation in my fifth rule. So what can we do? See, just an example, 2 to the power 3 divided by 4 to the power 3. Just consider like this. So it's nothing but 2 divided by 4. I'm combining both the bases and I'm putting as a single power. So this is what our answer. And we'll see the next rule. If a power has a negative sign in it, very important. If any exponent is having a power negative, we won't keep that as an answer always. Always our answer need to have a positive power. So in your question, first of all, if they have mentioned a negative power, we need to convert that to a positive power. So how to do that? See here, a general form I have given. X to the power minus y is there. See, minus y is the negative power. So I want to convert that to a positive power. So it is a positive power. If you are converting the negative power to the positive power, the very important thing is you need to take a reciprocal of a base. So here what is the base? It is x. What is the reciprocal of x? It is 1 by x. Why I am taking this reciprocal? Because I am changing the negative power to the positive power. That is the reason we are doing the reciprocal of the base. So we'll have an example. 2 to the power minus 3. Okay, so I am having actually here minus 3 as a power. So we need to change it to positive 3. Then what I have to do? Need to do the reciprocal of the base. What is the reciprocal of 2? It's nothing but 1 by 2. So these both are equivalent. So whenever we are solving the exponent and power, wherever minus is there, we have to convert to a positive power. This is a very important thing. And the next thing, some common facts in exponent and power. The first fact is any number to the power 0 is equal to 1. See, as I can write the general form like this, x to the power 0. X may be any number or it may be a long expression too. See here I have given a little small expression. Instead of this, you may have a long expression and having the power 0. Whatever it is, inside how much calculation it is, it doesn't matter. If the whole power 0, then the whole value is going to give the answer as 1 only. This is an important fact. And the next one, yeah, this is again one more important. See, minus 1 is there. Minus 1 to the power something is there. Usually, what is 1 to the power n? I'm going to multiply 1 for n number of times. How many times I multiply n also, I'm going to 1 also, I'm going to get 1 as an answer. How many times I'm multiplying 1, then I will be getting the answer as 1 only. But if I am multiplying minus 1 for n number of times, then what will be the answer? This n will play an important role, this power, because if this power is even, okay, see for example, if the power is even, consider as 2, what will happen? Minus 1 into minus 1. So when minus and minus will become plus, if there are two minus symbol, then if I multiply, I will be getting the positive symbol. Okay, that means pair of negative is going to become a positive integer. But see here, if this is 2 means it's an even number. Sure, all negative is going to have its pair. So obviously what will be my answer? Positive 1 only. Okay, so that is what here. Minus 1 to the power of 1008. 1008 times I need to multiply minus 1. So just to check whether this 1008 is even or odd. Yeah, it's even. So it is having pair of negative. So if there is a pair of negative, sure it's going to become a positive. So positive 1 is going to be our answer. Maybe if this minus 1 power is odd, what will happen? Sure, one negative is going to be left. So my answer is of negative. See, I can say like this. Minus 1 to the power 5. Small number we will take. So 5 is what I can write this as minus 1 has been multiplied for 5 times. So I multiplied. So what we considered, two pairs of, that means pair of negative is going to become positive and pair of negative going to be positive. Since it's an odd number, one negative is going to be left, okay, without any pair. So sure it's going to give the result as negative. So whenever you have minus 1 to the power any big number is coming, just check what that power, whether it is even means our answer is going to be positive 1. If it is odd, then the answer is going to be minus 1. And we'll see some basic problems in exponent and power. So the first question, see this express 343 as a power of 7. They itself gave the power of 7 you express. Sometime they may not give. Then at that time you need to do the prime factorization and convert that to as a power of exponent. Okay, see how I can do this one. 343, since they itself given as a power of 7, 7 is also a prime number, so yeah, going to do the prime factorization with respect to 7. So what it is actually, 7 fours are, yeah, 7 fours are 28, so balance 6, and 7 nines are 63, and here again with 7, yeah, then 7 to the power 1. So what, how can I express this 343 actually? It is equivalent to 7 into 7 into 7. A same number is multiplied for several number of time, then we can express that as an exponent. So it's nothing but 7 to the power 3. And we'll see the next problem. 729 and 125, you just express this in an exponential form, they told. So here they did not give you do with the power of 2, 3 like that. We are going to find it. So first we'll start with 729. So 729, in which table it will go? We'll start with the 3 table. So 3 twos are 6, balance 1, 3 fours are 12, and 3 threes are 9. And again 2, 4, 3. Again we can do with 3 table, right? So 3 eights are 24, and then with a 3 it is one time, and again with the 3 table, 3 twos are 6, and 3 sevens are 21. So I'm just writing here. Again with the 3 table, it's 9 times. Again with the 3 table, it is 3 times 3 one time. So 729 can be expressed as how much? How many threes are there? 1, 2, 3, 4, 5, 6. 3 to the power 6. So instead of I am mentioning 3 into 3 into 3 for 6 times, I am expressing this in an exponent form. Still we have 125, right? So we'll find what is 125. So we, since it is having the unit digit as 5, we can do a prime factorization with 5. 5 twos are 10, and 5 fives are, and 5 5. So 125 can be expressed as 5 to the power 3. But here these two are in a multiplication format. So I need to write the answer as 3 to the power 6 into 5 to the power 3. So the 729 into 125 can be expressed in an exponential form of 3 to the power 6 into 5 to the power 3. And the next problem, see, we are going to use the rule over here. So what is this? 3 to the power 6 divided by, division symbol is there. So I am putting a bar. The whole power 4 is there into 3 to the power minus 4. See here, 3 to the power 6, 3 to the power 8. What will happen? I need to subtract the powers. So I am subtracting the powers. So why I am subtracting the powers? Because division operation is there in between them. That's the reason. And here, see, it is of negative power, so I'm going to convert that to a positive power. So I'm taking the reciprocal, that's it. So 1 to the power 4 is going to be 1 only, so I'm writing 3 to the power 4 as such. Now what is going to be the result? 3 to the power 6 minus 8 is going to be minus 2. The whole power 4 is there into 1 by 3 to the power 4. See here, now power to the power calculation is there. So what will happen? We need to multiply. When the power to the power comes, we have to multiply the powers. So it's going to be 3 to the power minus 8 into 1 by 3 to the power 4. And again, it is having a negative power. So I have to write in a positive manner. So it will become 1 by 3 power 8 into 1 by 3 power 4. So what will be our answer now? I can write the numerator as such. 1 into 1 is 1, and here 3 to the power 8 into 3 to the power 4. Again you have same base and the power is different, so we can add the power using the multiplication rule, right? So 8 plus 4 is going to be 12. So this is what our answer for this problem. We'll see the next problem. So it is 27 into 3 to the power minus 3. So how can we express 27? 27 is nothing but it's 3 into 3 into 3. So I can express this as 3 to the power 3. And how can I express this 3 to the power minus 3? I want as a power positive. So now this become a reciprocal. What? The base will become as a reciprocal. So 3 to the power 3, 1 by 3 to the power 3. And 3 power 3, 3 power 3 will get cancelled. We will get the answer as 1. And next problem, see here, find the value of k. We are going to find the value of k, and this is an expression, we got it. So we'll start doing it. See, minus 2 to the power k plus 1. Again, we have same minus 2 as a base. Both are having a multiplication operation in between. So what can we do now? We can add the powers. Minus 2 k plus 1 plus 3 equal to, on our RHS we have minus 2 to the power 7. So this one I'm going to simplify k plus 1 plus 3. So it will become k plus 4. is equal to minus 2 to the power 7. Here again one more property. See, in an equation, both the side we have a same base. We have only one term and both the side we are having the same base. We can cut the base and equate the powers. This is one more rule also. So we can cut this minus 2 minus 2. Now we are going to equate the powers. So k plus 4 equal to 7. So if we solve k equal to 7 minus 4, so it's nothing but k equal to 3. So this is what the answer for this problem.